Today we're going to study distance between 2 points. Let us define the distance between 2 points. The distance between 2 points is the length of the straight line between those 2 points. I have here 2 points, and let us name these 2 points. The first point is P sub 1 with coordinates x sub 1 and y sub 1. The other point is P sub 2 with the ordered pair x sub 2, y sub 2. Let us connect these 2 points, and the distance between these 2 points is the length of this straight line. Let us draw a horizontal line segment that will pass through P sub 1, and it's here. Also, let us drop a vertical line segment that will pass through P sub 2. By doing this, we will form a right triangle here. Let us name the sides of this right triangle. In the rectangular coordinate system, this side here can be named as x sub 2 minus x sub 1. Also, the side here, considering the ordered pair of the P1 and P2, this side is y sub 2 minus y sub 1. By the triangle here, the D corresponds to the hypotenuse of the right triangle. So by the Pythagorean theorem, the square of the hypotenuse, which is the D, here we write D square, is equal to the sum of the squares of the two other sides. Let us write first this side, and we square this. So we write here x sub 2 minus x sub 1, and it is squared, plus the side here is the y sub 2 minus y sub 1. The quantity is squared. And to make this D without the square, we will take the square root of both sides. And this is now what we call the distance formula between 2 points. Let us have example 1. Calculate the distance between the points -3, -1, and -2, 4. Let us assign the first point to be the P sub 1 with the ordered pair x sub 1, y sub 1, and the second point to be P sub 2 with the ordered pair x sub 2, y sub 2. Then our distance formula is written here. Let us start substituting the values for our distance formula. Our x sub 2 is -2, then minus the x sub 1, which is -3. This group is now squared, and then plus the y sub 2 is +4, then minus y sub 1 is -1. This group is squared. Then let us simplify further. Let us remove the grouping symbol for its x and y's. So the -2 here is without the parenthesis. Then the minus and the negative becomes +3. The square is there. Then plus. The parenthesis of 4 is removed here. The minus and the -1 becomes +1. And again, we don't forget to write the square. Then we simplify further on the next step. The -2 plus 3 is now +1. And we copy the power 2, then plus 4 plus 1 is 5 square. Then we simplify the square now. 1 square is 1 plus the 5 square is 25. So 1 plus 25 is 26. So the distance is equal to the square root of 26. We put the word units, and this is our final answer. There is a question here. What will happen if the p sub 1 and p sub 2 are interchanged? It means, can we use the first point to be p sub 2 and the second point to be p sub 1? Let us solve that one. So I put here the first point to be the p sub 2 and the second point here to be p sub 1. Let us solve using our distance formula. Let us substitute the values. The x sub 2 is the negative 3, then minus x sub 1 is negative 2. Of course, we write the square, then plus y sub 2 is negative 1, then minus y sub 1 is positive 4. Then let us simplify this equation. We remove the grouping symbol from negative 3. It is now written here. The minus and the negative 2 becomes plus 2. We write the square, then plus. We remove the grouping symbol from negative 1. It is now negative 1 here. Then minus of this positive 4. So we remove the grouping symbol. And the square is copied. Then we simplify further. The negative 3 plus 2 becomes negative 1. Then the square is there. Plus negative 1 minus 4 is negative 5. The power 2 is copied. And then we simplify on the next step. The square of negative 1 is positive 1. The square of negative 5 is positive 25. So 1 plus 25 is 26. So our distance is equal to the square root of 26. This is our final answer. Our answer to the question is, when we use the first point to be p sub 1 and the second point to be p sub 2, or vice versa, the derived distance will be the same. Let's have example 2. Calculate the distance between negative 5, 3 and negative 9, 6. Let us assign the points. Let this be the p sub 1 and the other point to be the p sub 2. Our distance formula is here now. Let us substitute the values. Our x sub 2 is negative 9 minus x sub 1 is negative 5. We put the square and then plus. The y sub 2 is positive 6 minus the y sub 1 is positive 3. And we put the power 2. Then we simplify further. We remove the grouping symbol of negative 9. It's now without the parenthesis here. The minus and the negative 5 becomes plus 5. We copy the square. Then plus. We remove the parenthesis for the 6 and for the 3. The minus sign is simply copied here. Then we simplify further. The negative 9 plus 5 is negative 4. And then that is squared plus 6 minus 3 is 3. We copy the power 2. Then we simplify again. The square of negative 4 is positive 16 plus the square of 3 is 9. 16 plus 9 is 25. And we can simplify the square root of 25 to be 5. And our answer for the distance is 5 units. Example 3. Prove that the points P, which is 3, 2, point Q, negative 2, negative 3, and point R, and that is 2, 3, form a right triangle. Let's write the distance formula. Let's begin with the side PQ. Using the distance formula, we have now 3 minus negative 2, that is squared, plus positive 2 minus negative 3, then we will square. Let us simplify the radicand. This 3 minus negative 2 will be positive 5, then we will square later. Plus 2 minus negative 3 is positive 5 that we will square. Now the square of 5 is 25 plus 5 square is also 25. 25 plus 25 is 50. So for the PQ, we have square root of 50. Next, the side QR. By distance formula, we write negative 2 minus 2, then we will square, plus negative 3 minus positive 3, then we will square. Let us simplify the radicand. Negative 2 minus 2 is negative 4, then we will square, plus negative 3 minus 3 is negative 6, then we will square. The square of negative 4 is 16, plus square of negative 6 is 36. The sum of 16 and 36 is 52. So for the QR, the answer is square root of 52. Next, side PR. By distance formula, we have now 3 minus 2, that is squared, plus 2 minus 3, that is squared. Simplifying further, 3 minus 2 will be 1, that will be squared, plus 2 minus 3 is negative 1, then we will square. 1 square is simply 1, square of negative 1 is 1. 1 plus 1 is 2. So for the side PR, the answer is, or the distance, square root of 2. Since the square of side PQ plus the square of side PR equals the square of side QR. To show this, we can substitute the corresponding values. So, square of PQ will be square of square root of 50 plus the square of PR will be the square of square root of 2 equals the square of side QR is the square of square root of 52. Then we cancel the radical with the corresponding exponent. We have now 50 plus 2 equals 52. Then the left side is 52 equals right side, which is 52. By the converse of Pythagoras theorem, we have an angle P that is 90 degrees. Therefore, the triangle PQR is a right triangle. Example 4. Show that the points A, 1, 7, point B, 4, 2, point C, negative 1, negative 1, and point D, negative 4, 4, are the vertices of a square. Let us show that all sides are equal and show that the two diagonals are equal, so that the 4 points here are vertices of a square. Let's write the distance formula. Then we have the 4 sides. Let's begin with the side AB. By distance formula, we have now this 1 minus 4, that is squared, plus 7 minus 2, then we square. 1 minus 4 is negative 3, and then squared, plus 7 minus 2 is 5, then we will square. The square of negative 3 is 9, plus 5 square is 25. The sum is 34. So for the side AB, It is square root of 34. Now, side BC. By distance formula, we substitute the values as 4 minus negative 1, then we will square, plus 2 minus negative 1, then we will square. This 4 minus negative 1 will be 5, that is squared, plus 2 minus negative 1, that is 3. Then we will square. 5 square is 25, plus 3 square is 9. 25 plus 9 is 34. Therefore, for the side BC, the length is square root of 34. What about the side CD? By distance formula, we have the values negative 1 minus negative 4, that is squared, plus negative 1 minus 4, that is squared. Negative 1 minus negative 4 is positive 3, then we will square, plus negative 1 minus 4 is negative 5, then we will square. 3 square is 9, plus square of negative 5 is 25. 9 plus 25 is 34. Therefore, the length of the side CD is square root of 34. Then the side DA. By distance formula, it becomes negative 4 minus 1, that is squared, plus 4 minus 7, that is squared. Negative 4 minus 1 is negative 5, that is squared, plus 4 minus 7 is negative 3, that is squared. The square of negative 5 is positive 25, plus square of negative 3 is positive 9. 25 plus 9 is 34. For the length of DA, we have square root of 34. We can see that the sides are equal in length, which is square root of 34. Now, the two diagonals. The first diagonal is from points A to point C. So this is AC. By distance formula, we write 1 minus negative 1, that is squared, plus 7 minus negative 1, that is squared. 1 minus negative 1 is 2, that is squared, plus 7 minus negative 1 is 8. Then we will square. 2 square is 4, plus 8 square is 64. 4 plus 64 is 68. AC is with length square root of 68. What about the length of BD? This is the second diagonal. By distance formula, we write 4 minus negative 4, that is squared, plus 2 minus 4, that is squared. 4 minus negative 4 is 8, then we will square, plus 2 minus 4 is negative 2, then we will square. 8 square is 64, plus negative 2, that is squared, is positive 4. 64 plus 4 is 68. So for diagonal BD, the length is square root of 68. Since the side AB is equal to the side BC equals the side CD and the side DA. Also the diagonals AC equals BD. Then the 4 points are the vertices of a square. Example 5. In a classroom, Ashima, Bharti, and Camelia are seated at point A 31, point B 64, and point C 86 respectively. Prove that they are seated in a line. To prove this, let us show that AB plus BC equals AC, so that the girls are seated in a line. We write the distance formula. We start with the length AB. So we have the square root of 3 minus 6, that is squared, plus 1 minus 4, that is squared. 3 minus 6 is negative 3. We will square, plus 1 minus 4 is negative 3. Then we will square. Negative 3 squared is 9, plus Negative 3 squared is also 9. 9 plus 9 is 18, and we can simplify this into 9 times 2. This 9 is a perfect square number that we can pull out outside the radical sign. So we have 3 square root of 2 for the length AB. What about the length BC? By distance formula, we have 6 minus 8, that is squared, plus 4 minus 6, that is squared. 6 minus 8 is negative 2, that we will square, plus 4 minus 6 is negative 2, that we will square. Square of negative 2 is 4, plus square of negative 2 is also 4. 4 plus 4 is 8. This 8 inside the radical sign, we can show that this is 4 times 2. This 4 being a perfect square number, we can pull out of the radical sign. So this is simplified into 2 square root of 2. Now for AC. By distance formula, we write 3 minus 8, that is squared, plus 1 minus 6, that is squared. 3 minus 8 is negative 5, that we will square, plus 1 minus 6 is negative 5, that we will square. Square of negative 5 is 25, plus 25. The sum is 50. We can simplify this as 25 times 2. This 25 is a perfect square number. We can simplify to pull it out of the radical sign. So this is 5 square root of 2. Now let us show that AB plus BC equals AC. When we substitute the values, we have 3 square root of 2 plus 2 square root of 2 equals 5 square root of 2. The left side becomes 5 square root of 2, which is equal to the value of the right side. Since AB plus BC equals AC, then the girls are seated in a line.